All right, we're going to do a little bit of a review on volume of rectangular prisms. As you can see, the volume again is length times width times height. Or if they're given the area, which is the same as the length and the width, which is basically the bottom, you're just going to multiply that by h. So volume is length times width times height, or volume is the area of the base times how tall it is, the height. Okay, so we are going to look at this and we are going to find the area of different sides. So if I give it some dimensions and I give it an area of, or a side of 2 there, this is going to be 3/4 right there. And the height, we're going to go as 1 and 1/4. So I know the length, the width, and the height. So if I know the length, width, and height, I would use this formula right here. Volume is length times width times height. Okay, now I just plug in the numbers I have. So the length is 2 times 3/4, which is 3/4, times 1 and 1/4. Well, we have 1 and 1/4, but we can't use it in that form. We need to make this an improper fraction. So 4 times 1 is 4, plus the other one is 5. So it is times 5/4. So I have 2 over 1 times 3/4 times 5/4. Okay, so what I'm going to do is 2 times 3 is 6, times 5 is 30. So my numerator is 30. Okay, my denominator is 4 times 4 is 16. So I have 30/16. I could simplify this to 15/8 by dividing both sides by 2. So I cut it in half and I have this. Now make it back to a mixed number. 8 goes into 15 one time. There's 7 pieces left out of a denominator of 8. So 1 and 7/8 units cubed. Or the fancy way of doing this, 2 goes in there once, 2 goes in there twice. So I would have had 15/8 right there, which is the same thing we simplified down there, giving us 1 and 7/8. Okay, so that's how you do it if you're given volume is length times width times height. Now, let's see another example. What if I'm given something a little bit different? What if I'm given the area of the bottom? Let's say the base of this has an area equal to 10. However, you get that, length times width, 5 times 2, 10 times 1, it doesn't really matter. But the area of the base is 10. And we're going to give you a height of 5. So if I know an area and I know a height, I want to use the volume is area times height. So I know what this is. It's 10. I want to see how many times I have to stack this up to get to the top. And the answer to that is 5. So if I stack 5 of these up, what am I going to get? So volume is area times height. Volume is area is 10, height is 5. So the volume is 50 units cubed. So if I stack 5 tens up, I'm going to get 50. Okay. And final little one here. Okay. Now, using the same problem we did in the first one, we had this as 2. This was 3/4. And this was 1 and 1/4 as my height. Okay, so we found out the volume of this was, from the first one, was 1 and 7/8, I believe. Okay, but now I don't want to find the volume. I want to know how many 1/4 inch cubes can fit inside this. So if I had a regular 1-inch cube, I could fit 2 of them this way, at 3/4 of one this way, and 1 1/4 that way. But I'm not looking for a regular cube. I'm looking for a 1/4 cube. So I want to know how many 1/4 can fit that way. So if it's 2 that way, I know 4/4 makes 1, so 8/4 must make 2. So 8 1/4 makes 2. How many 1/4 go into 3/4? Well, 3 of them. 1/4, 2/4, 3/4. 3 of them. How many 1/4 go into 1 1/4? Well, 4 go into the 1, then you need one more 1/4, so that is 5. So I could have a row of 5 of these. And I could have 3 rows of 5. Don't forget what I just said. So I could have a row of 8 of these. So 8 cubes going this way, but I could have 3 rows of those 8. So I would do 8 times 3, and that's just would give me the flat bottom, and I can stack those up that many times, which is 5. So 8 times 3 times 5. 8 times 3 is 24. 24 times 5 is 120. So I could have 120 cubes. So when they're asking how many fractional cubes in there, find out how many of these fractions go in each direction, then multiply them like you're doing volume. Hopefully this helps you, and good luck with your problems today. Goodbye.